All right, now we're going to be moving into what we call radicals, or people call square roots. The first part, the first 4 questions that I see here, we have to square each radical. Make sure you guys read the instructions. If we take a look at the first 8 questions, the questions look very, very similar. However, the instructions on the first 4, it says square each radical. Questions 5 through 8, it says simplify. So make sure you guys read the instructions. Don't just look at the question. Make sure you guys read the instructions. Looking at question number 1, we're going to square. What square means is that we're going to multiply 2 radical 5 times 2 radical 5. All right, we're going to square it. Now, whole numbers with whole numbers go together. So let me just say it. I'm going to have 2 times 2, right? The whole numbers, the numbers that we see outside. And then together, I'm going to have the radicals. Radical 5 times radical 5. Whole numbers go with whole numbers and radicals go with radicals. Now, in the whole numbers, 2 times 2, well, that's 4. Let me keep that inside parentheses. The interesting part is that when you square a radical, when I see this second parentheses, let me emphasize it right here. It's radical 5 squared. We know that addition and subtraction undo each other. We know multiplication and division, they undo each other. Now, radicals and exponents, they undo each other. So when you square it off the square root of 5, all you get is 5. The square root and the second exponent, they undo each other. So I'm just going to get the number in the inside. So in this case, 5. All right, so when I multiply my whole numbers, I got a 4. When I multiply my radicals, I got a 5. So when I multiply these two, 4 times 5, I'm going to get 20. When I square a radical, I will always, when I square a square root, I will always have a whole number. So on the quiz, when you run into something like this on the quiz, it will just say all numerical. It will not let you turn in anything else. It's just a plain number. Now let's take a look at number 2. I have 5 radical 28 times 5 radical 28, or square root of 28. Inside parentheses, let me just write 5 squared, right? Because I have 5 twice. Inside the other parentheses, let me put my square roots. And I have the square root of 28 squared. Now from the first parentheses, 5 squared, right? 5 times 5, that's 25. On the second parentheses, square root of 28 times the square root of 28, that's just 28. I said earlier, a square root and a squared exponent, they undo each other. So now I'm just going to have 25 times 28, and that gives me 700. Don't be afraid if some of your answers are in the thousands. It is possible to be in the thousands. Let's take a look at question number 3. I'm going to have 2 square root of 12. Let me put that inside of parentheses, times 2 square root of 12, right? Because I'm squaring it. What I'm going to do, like I mentioned earlier, whole numbers with whole numbers. So 2 squared. And then radicals together, square root together. So I have the square root of 12 squared. My first parentheses, 2 squared is 4. The square root of 12 squared is just 12. Then I have 4 times 12, which is 48. I think we get the idea, but still let me do number 4. I have 5 radical 21 times 5 radical 21. Remember, for the first 4 questions, it was square. So basically multiply by itself. So I'm going to have 5 squared, the whole numbers, 5 squared, And another parenthesis, just the square roots. The square root of 21 squared. My first parenthesis, that gives me 25. The second parenthesis, the square root of 21 squared is just 21. So 25 times 21, it gives me 525. Again, you might be in the thousands, and that's fine. Now, what happens if you happen to have a perfect square root? Question is, what happen? I have a question here in the chat. What happens when you have a perfect squared in the square root and a number on the outside, for example, 2 square root of 12? Now, the square root, it will just become a whole number. The 2 on the outside is just a whole number. Interesting part is that whether inside of the square root I have a perfect square or not, everything becomes just a whole number. The square root with the square exponent, they undo each other. Now, squaring, the first 4 questions shouldn't be that difficult. Notice how in all of my answers, I just had a number. Like I said, don't worry if you guys are in the thousands. Some of in your homework or your quiz, you might be in the thousands. Now, the interesting part, the challenging part is when we simplify. Let me take a look at questions 5 and on. Now, one thing is that we know how to simplify perfect squares. Right? We know that 2 squared is 4. So the square root of 4 is 2, right? We know perfect squares. We know the square root of 4 is 2. We know the square root of 9 is 3. We know the square root of 16 is 4, right? Perfect squares are those that give me a whole number. We know the square root of 25 is 5. And then we can go on and on and on, right? We have talked about the perfect squares before. Now, when they're not perfect squares, I'm looking at question number 5, the square root of 80, because I know the square root of 36. I know the square root of 49. I can go on, but I'm not going to get to square root of 80. Square root of 80 is not a perfect square. If I type it into my calculator, it gives me a decimal. For today, I'm not asking for decimals. I'm asking you to simplify. I'm not asking you to estimate. Estimate our decimals. Simplify, just make the number smaller. What I'm going to do, square root of 80, I'm going to break it down as to 2 square roots. I'm going to break it down as 2 radicals. One of them has to be from my list of perfect squares. So it has to be either 4, 9, 16, 25, 36, 49, any of those. For starters, I'm going to say, well, I could go 4 times 20. I'm going to think of 2 numbers that multiplied equals 80, but one of my numbers has to be from the list of perfect squares, because this is going to simplify to 2 radical 20. Right? The square root of 4 becomes a perfect square. So the outside is a 2, and I still have square root of 20. And then I'm going to say, if you can simplify more, by all means do so. When I'm thinking of square root of 20, I can say, well, I can do square root of 4 times square root of 5. Remember, this became a 2. Now, my 20, I went as 4 times 5, right? Square root of 4 times square root of 5, because the square root of 4 becomes a perfect square, which is 2. Now, earlier, when we were squaring, I said whole numbers with whole numbers. So this 2 with this 2 that goes outside, I'm going to multiply it. So my answer will be 4 square root of 5. For right now, let me just focus on how to do the work. I'll come back into how we simplify. or how we're going to type it in on their homework. For right now, let me just worry about how to do the work. Then we're going to do some others. Let's see. 245. I'm going to break this into 2 square roots. Now I cannot divide, I cannot do it as 4 times something, right? I'm thinking of 2 numbers that multiplied equals 245, but one of them has to be from my list of perfect squares. And I tried, okay, 245 divided by 4. I tried on my calculator, and it gives me a decimal, so it doesn't work. How about 245 divided by 9? It doesn't work. 245 divided by 16, it doesn't work. By 25, it doesn't work. But 245 divided by 49 is 5. So I know 49 times 5. 49 times 5 is 245. The way I came up with those 2 numbers, first I tried 245 divided by 4. Didn't work. Divided by 9, divided by 16. Didn't work, but 245 divided by 49 gave me 5. So then I know 49 times 5. I know the square root of 49 is 7. So my answer will be 7 square root of 5. My square root, I cannot simplify anymore. So that's my answer. Like I said, I'll come back later to see how we type this. But for right now, let me just leave it at that. Now, 320, looking at question number 7. I'm going to break it down into 2 radicals. I know I can go 4 times 80, but I can also go 16 times 20. Actually, I could go 4 times 80, and it does simplify to 2 radical 80, but I can also go square root of 16 times square root of 20, right? 16 is my perfect square. The bigger, the better. So I know this is going to simplify because the square root of 16 is 4. So this is going to simplify to 4 square root of 20. We can simplify the radical more, by all means do so. I'm going to break this as the square root of 4 times the square root of 5, because the square root of 4 is 2. Now these 2 whole numbers, this is going to give me, I'm going to write my answer down here. It's going to give me 8 radical 5, or 8 square root of 5. Notice how my whole numbers are multiplied. And then looking at number 8, let me break that as 25 times 5. Notice I'm doing 2 square roots. One of them has to be perfect. I know the square root of 25 is 5. My answer is 5 square root of 5. Now let me worry about how are we going to type this. For question number 5, I'm going to type in a 4. I'm going to do in red the typing. 4 square root of 5. The way we type it in is SQRT. That means square root. And then open and close parentheses. But inside the parentheses, I'm going to type in a 5. So 4 square root of 5. If you're looking at number 6, 7 square root of 5, we're going to go 7 SQRT, open and close parentheses, but inside the parentheses, I'm going to do a 5. 7 square root of 5. And then for number 7, it's going to be 8 square root of 5. And then number 8 is going to be 5 square root of 5. Now, question number 9 through 12, we're still simplifying, but we have fractions. One thing we're going to do is we cannot have radicals at the bottom. We cannot have square roots. It's okay to have it on the top, but we cannot have it at the bottom. So my thing first is, let me see if I can simplify my fractions, and hopefully, the square root at the bottom is a perfect square. So I don't have a square root at the bottom. Questions number 9 and 10, the square root at the bottom is a perfect squared. So that's going to be nice. I see that to begin with, this 2 with this 2 cancel out. So then I have square root of 8 over 2. Right? Because the square root of 4 became a 2. But then I ask myself, can I simplify my radical from the top? My radical from the top, I can break that as square root of 4 times square root of 2, which simplifies to 2 radical 2. I have a 2 at the bottom. Those 2's cancel out. So my answer is just square root of 2. I don't have a fraction anymore. Now looking at number 10, the square root of the bottom. Like I said, first I look, is the square root of the bottom a perfect squared? Which it is. It is. Square root of 9 becomes 3. So just to simplify things, I have the square root of 8 over 6. Notice how my numbers at the bottom, 2 and 3, have multiplied. But then I also ask myself, can I simplify the square root from the top? Just looking at the top, I can break that as square root of 4 times square root of 2, because the square root of 4 becomes a whole number. So on the top, I have 2 radical 2. At the bottom, I have a 6. I see 2 over 6. I see my whole numbers. I know how to simplify fractions, so that's basically 1 over 3. So my answer will be the one outside of the radical we don't have to write. So my answer will be square root of 2 over 3. Now, how am I going to type that? The way we type fractions, let me see. The way we type fractions, we're going to do a slash like this. You guys should see that at the bottom right of your keyboard. That's how we're going to write fractions. Anything before that is what goes on the top. Anything after that, it what goes at the bottom. So I'm going to have SQRT 2. So square root of 2 over 3. Again, I have a backslash. Anything before that goes on top of the fraction. Anything after that is what goes at the bottom of my fraction. If there's a negative sign, whether it's on the top or the bottom, I bring it to the very, very front. So if there is a negative sign, bring it to the very, very front. All right, now let's take a look at number 11. Unfortunately, the square root at the bottom is not a perfect square. So I'm going to try to simplify things out. When I see there's a 4 on the outside, so I'm going to leave that on the outside at the bottom. My focus is just on the square roots. Now, like I said, if the one at the bottom was a perfect square, nice. Make it a whole number, and we're good to go. If it is not, treat the 2 radicals, the 2 square roots, treat them as a fraction. I know 2 over 8, that simplifies to 1 over 4. Right? 2 over 8, if it was just numbers, 2 over 8 is 1 over 4. So the square root of 2 over the square root of 8, make it the square root of 1 over the square root of 4. Right? Make it a fraction of radicals, or make it a fraction of square roots. Now, the nice thing is the radical at the bottom, the square root of 4, I know it's a perfect square. But interesting is that the square root of the top also became a perfect square. So my answer right now, I have 1 over 8. Notice I multiply my whole numbers at the bottom. Whole numbers can be multiplied. And obviously, how are you going to type that? I'm going to go 1 over 8. And again, if there was a negative sign, because sometimes you guys will run into negative signs, whether the negatives on the top or the bottom, I bring it to the front. All right, let's take a look at question number 12. I'm going to simplify first. I see 4 over 2. That's basically 2 over 1. The 1 I don't have to write, so I'm just going to write a 2 on the top. Then I look at my square roots. If the 1 at the bottom was a perfect square, nice, right? Make it a whole number, we're good to go, but it is not. So I'm going to make it a fraction of 2 radicals. And I'm thinking the numbers, 10 over 18, divide each by 2, that gives me 5 over 9. The nice thing is that the 1 at the bottom, the square root of 9, becomes a whole number. So now I have 2 square root of 5 over 3. My square root on the top is simplified. Nothing I can do. My whole numbers, 2 over 3, nothing I can do. So that's my answer. The way I'm going to type this in, I'm going to go 2 square root of 5 over 3. For the square roots, couple things. Don't forget to close your parentheses. Another thing, keep all your letters lowercase. Don't capitalize any of the letters. Now let's move into something easy. Let's take a look at questions number 13 through 16. State if each triangle is acute, obtuse, or right. Now we're going to learn a couple of things. We've heard of a squared plus b squared equals c squared. We've learned of those. So we have heard a squared plus b squared is equal to c squared. You guys have heard Pythagorean theorem. That works every time we have a right triangle. So I'm going to say this only works when we have a right triangle. A squared plus b squared equals c squared. From the 3 sides of your triangle, c is the biggest. A and B are the other 2. It doesn't matter which one's A or which one's B, as long as C is the biggest. But then for today, we're going to move into other 2 rules. A squared plus B squared is greater than C squared, right? We're not going to have the equal sign. If A squared plus B squared is greater than C squared, we're going to say our triangle is acute. And if we happen to have A squared plus b squared is less than c squared, then we're going to say our triangle is obtuse. So I'm going to be asking, state if each triangle is acute, obtuse, or right. Now I'm squaring everything. If you notice on the rules, I have a squared, b squared, c squared. I'm squaring everything. So to begin with, let me square all my numbers. When I look at 8 squared, right, 8 squared is 64. So I'm going to square everything. 7 squared is 49. And then the square root of 13, all squared, is just 113. Remember at the beginning of today's lecture, we said that when we square a radical, when we square a square root, we just get the number on the inside. So then I have 64. The way I'm going to do this, I'm going to add the 2 smaller numbers, right? A squared plus b squared, 64 plus 49. Let me leave a space because I don't know if I have an equal sign, greater than, less than, and then 113. The biggest number is the one that I put by itself. I add the 2 smaller numbers. Keep in mind, I already did the squares, so I don't have to square them again. Now 64 plus 49, that's 113. The other side is 113. I have an equal sign. And I said earlier, we get the equal sign when the triangle is a right triangle. So my answer will be right. Now, when our answers are words, right, our English department, I remember they said every time you write words, we call it sentence. And every time you start a sentence, you're going to capitalize the first letter. Notice I capitalize the first letter. So make sure you go capital R. All right, let's take a look at question number 144. Again, let me square each of my sides. Squaring perfect square, squaring square roots is easy because the square root of 122 all squared is 122. The square root of 134 all squared is 134. When you squared a square root, you basically get the number in the inside. Now, 19 squared, now that's not a perfect square, so I have to go 19 times 19. Now I get 361. Right? 19 is not a square root, so I have to actually multiply it. I'm going to add the two small numbers, 122 plus 134. Let me leave a space, and then 361. If I add the two small numbers, 122 plus 134, I have 256. And then here I have 361. Okay, I don't have an equal sign. So matter of fact, C was bigger, right? C squared is still bigger. So in this case, I'm going to call this obtuse. Let me come back to my rules. When I have an equal sign, it's a right triangle. When C squared is smaller than the other two, I have an acute. But when C squared is still bigger, I get an obtuse. Let me take a look at a couple more examples. Let's take a look at number 15. I'm going to square everything. 10 squared is 100. 12 squared is 144. The square root of 245 all squared is just 245. Again, when we squared a square root, we just get the number in the inside. Let me add my two small numbers, 100 plus 144. Let me leave a space, 245. Let me add the two small numbers. That gives me 244. Here I have 245. All right, a squared plus b squared is less than c squared. According to our rules, this is obtuse. Then looking at number 16, let me do the easy ones first. The square root of 10 all squared. Now, question here is, how do you determine which number it is C? The biggest one. The bigger one is C. So I'm going to square everything. So here, let me start with the easy ones first. The square root of 10 all squared is just 10. The square root of 14 all squared is just 14. Now, the square root of 2 times, no, 2 radical 2 all squared. Okay, now that one, let me work it out, because I have 2 square root of 2 times 2 square root of 2. And I remember from the beginning of today's lecture, I said, combine the whole numbers. I have 2 squared. And then combine the square roots. And that gives me 4 times 2, which is 8. So this little side is 8. When it's just a whole number, it's easy. I'm going to come back to 16. I'm not done. When it's just the whole number, I'm looking at number 15, like 10 and 12. It was easy to do a square root. When it was just a square root, it was easy. You just get the number in the inside. Now, when it is a mixture of a whole number and a square root, you have to square each of them. All right. Remember, I'm going to add the 2 small numbers. So let me go 10 plus 8. And then 14, right? I left the space. So I have that 18 and 14. I know 18 is greater than 14. And according to our formulas, when I have a squared plus b squared greater than c squared, I get acute. And like I mentioned earlier, when we write words, make sure you capitalize the first letter. All right, let me zoom out. Let me zoom out so you guys can see what we did. Let me leave it there.